off today simplifying radicals. And switching between rational exponent and radical form. Okay, we're going to start off with something really easy. All right, 36 to the 1/2 power. All right, so right now, this is a rational exponent. Rational means can be written as a fraction. So my exponent is a fraction. Now, we actually learned about this in geometry, but it's been a while, so I'm going to pretend like you don't know. Okay? So what does this rational exponent mean? This bottom number tells us the root that we're going to take. And since it's a 2, it means square root. If it were a 3, it would mean cubed root. For a 4, it would mean fourth root. Okay? And then the top number of a rational exponent gives us the power that we're going to raise that to. So 36 to the 1/2 really means it's got a 2 for my root, so that's square root. Now square root's really common, so when there's not a number right here, it means square root. So we don't have to put a little 2 right there because we know that the radical means square root. And then we're going to raise that to the first power. Well, what is the square root of 36? 6. And 6 to the first power is just 6. So 36 to the 1/2 is 6. Okay? Let's mix it up. Let's do a different root. Let's do 8 to the 2/3 power. So, with my rational exponent, the denominator represents the root. So this time it is a cubed root. Now I do need to put the little 3 here to indicate cubed root. And then my power is 2. So the cubed root of 8 is 2, and 2 squared is 4. Okay, let's do negative 27 to the 2/3. So this time we do the cubed root of negative 27, and then we square that. Now, we have to be careful here. We have a negative under the radical, but it's an odd root. And we can take odd roots of negative numbers. If we tried to take an even root of a negative, we'd get I, wouldn't we? But we can take odd roots of negatives because a negative times a negative times a negative is negative. So the cubed root of negative 27 is negative 3. But then when we square that, it does become positive 9. Okay. Let's throw a fraction in here and raise it to a rational. Okay. What is the root? Is it cubed root or square root? Square root. The denominator gives me the root. So this is the square root Now remember, when we have a fraction under the radical, it really means take the square root of both those things, doesn't it? You don't have to write it like this, but I just wanted to remind you it means take the square root of both of them. So what's the square root of 4? 2. And what's the square root of 9? 3. And then we cube those. 2 cubed is 8. 3 cubed is 27. Okay, now what would happen if I took this same thing, but instead of doing it to the 3 halves, we did it to the negative 3 halves? What did we say yesterday that negative exponent does? It flips it, it's reciprocal. So really, this is the same as 9/4 to the positive 3 halves. So all it's going to do is take our answer and flip it, because it's the square root of 9 and the square root of 4 cubed. So it's 27 eighths. Okay, so if we just had a plain old number, like we had 16 to the negative 1/4. If it's just a plain old number and not a fraction, you can think of it as 1 over 16 to the 1/4. So this time it's what root? It is the 4th root.
Why don't we just do the whole thing for 1 Like, why do you want to do it as a problem?
You could do the 1, but 1 to any power is just 1. Still. So you thought about it like this, and then you flipped it? Sure, you could. But and 1 to any power is still just 1. All right, 4th root of 16. What can we multiply times itself 4 times and get 16? 2. So it simplifies to 1/2. All right. Now, this is a variable, and I can't really simplify it, but I can switch forms. This is the same as the square root of x. Okay? Now what if I started out like this? X to the 3/4. This is the same as the 4th root of x cubed. Or the 4th root of x cubed. Why do both ways work? It is, because if I think of x to the 3/4 as x cubed to the 1, actually let me write that under here, x cubed to the 1/4. Do you see how this gives me this answer? And what is 3 times a 4? 3/4. Or I can think of it as x to the 1/4 cubed. Do you see how 1/4 times 3 is 3/4? 3 times a 4th is 3/4. Both these mean the same thing. So this is the 4th root of x cubed. This is x cubed, the 4th root of x cubed. All those are equivalent. Now the reason I tell you that is because I think if you see this on an SAT or an ACT, they're probably going to give you 3 choices that are right and 1 choice that's wrong. And all of these mean the same thing. All of those mean the same thing. So you need to know that this is the same thing as this, is the same thing as this, is the same thing as this, is the same thing as that. They're all equivalent. And if you had one of these on the SAT, I think that's how they get it. Those all mean the same thing. Okay. All right, what we just did will help you with 1 through 10 on your homework. It's the back of the worksheet we just worked on a second ago. What we just did. So now let's tackle the bottom part. The bottom part says, okay, now let's go the other way. Let's say we start with a radical. Can we write it as a rational exponent? So if I started with this radical, the 5th root of x, can I write it as a rational exponent? All right, sure. What's the power? It's an understood 1. What's the root? 5. Power over root. Okay, let's do the cubed root of x to the 4th. Write it as a rational exponent. What's the power? 4. What's the root? 3. All right. Now, this is what is under the radical. And the root is a cubed root. So that's the same as the 1/3 power. Now, could I distribute that power or raise each of these to that power? Distribute is the wrong word there. Can I raise each of these to this power? Sure. This means the same thing. But B would be to what power? 2/3.
That was correct. Can you run me
I would want you to be able to do both. Yes. Okay? And the reason why is this. Because sometimes it simplifies really nicely. All of this is raised to the 1/3 power. So that means 27 to the 1/3. A to the 6/3. Ooh, that divides nicely, doesn't it? And B ends up being to the 9/3. That divides nicely, doesn't it? So this gives me A squared, B cubed, and 27 to the 1/3. It does simplify. What is the cubed root of 27? 3. Okay, this answer right here is where we have simplified our radical. And if we think in terms of rational exponents, it helps us to simplify radicals. So that's the last thing we're going to talk about today. How can I simplify a radical using a rational exponent? Okay? Okay, so this is just a square root. That's all this one is, a square root. So I can think about it this way. Now square roots we're already kind of used to, aren't we? You guys know the square root of 25, don't you? What is it? 5. Now what happens when I raise this 6 to the 1/2 power? Can I take half of 6? Yeah, what is half of 6? 3. It gives me x to the 3rd, doesn't it? Now, when I take half of 5, I don't get a pretty, I get a decimal. But how many times does 2 go into 5? Twice. How many is left over? 1. 2 goes into 5 2 times, and 1 is left over. So when we're simplifying radicals, the best way to do it is to think about it as a rational exponent. How many times does this denominator go into that exponent? 2 goes into 6 exactly 3 times. How many times does this denominator go into this exponent? 2 goes into 5 2 times, but there is 1 left over. Let's do it. Did y'all do some of this last year? No? Okay. Let's do a cubed root. All right. Do you know the cubed root of 8? Yeah. What's the cubed root of 8? 2. Okay. Cubed root is the same as what power? 1/3 power. So what am I dividing into all these exponents this time? 3. How many times does 3 go into 10? 3 times. 3 goes into 10 3 times. Are there any left over? 1. So we're going to leave 1 under the radical. How many times does 3 go into 12? 4 times. Are there any left over? No. How many times does 3 go into 13? 4 times. How many are left over? 1. Now, what happens if instead of this number being 8, that number was 48? We don't know the cube root of 48. But we do know that 48 is 8 times 6. Is it 48 8 times 6? We can take the cube root of 8. The cube root of 8 is 2. We don't know the cube root of 6, so where would it go? It would go under the radical. I changed the problem. I said, what if instead of this being 8, it were 48? And so whenever we're asked to simplify a radical that's not a perfect square or it's not a perfect cube, you have to break it down. Just like when we did things like the square root of 50, and we would say 50 breaks down into 25 times 2, because 25 is something we know the square root of, and we would say that's 5 square roots of 2. We can also do it when it's radicals other than square roots. Okay, so let's take a look at your homework and let me talk about what I want from you. This part up here, very self-explanatory. First, write it as a square root, and then simplify if possible. Follow those directions exactly. Okay, so that's follow the directions exactly. Write it as a square root, and then simplify if possible. All right, the bottom part. I'm going to ask you to do a little bit more than it says, just because I want you guys to be 100% ready for that SAT and ACT. So, I want you to write it using a rational exponent. That's the easy part. So this would be, let's do this one together. This would just be a to the 7 thirds. That's pretty easy. Now, part B for me is I want you to write it in simplest radical form. Now, there is some academic discussion about this direction, because simple means it should look easier. And these answers, when you simplify them, do not look easier. Because to simplify it, I'd have to say, all right, 3 goes into 7, how many times? 3 goes into 7 2 times, and how many's left over? 1. So this would be your answer to part A. This would be your answer to part B, which I'm asking you to do. Okay? You do not have to do any more on the front, just the back.